Hello everyone, welcome to the 7th episode of FPGA Limerick. In this episode, we will get our hands dirty to build the Hello World example mentioned in the previous episodes. And then we will also to load the bit files onto our FPGA board to show a blinking LED. By the way, the script of this episode has already been posted online at fpga.pausering.com. Yes, here's our companion blog, fpga.pausering.com. First of all, as we mentioned in the first episode, we will use the RTA7-100T board from Digilent as our main FPGA dev board. The board can be found in this link. Let's take a look. Yeah, here is the board we will use. And also I think we have a live shot of this board and on our bench, and we will show, we will do a demo quickly on later. Okay, so here's our board, and also before we start, we need to do the tool installation. I think the first tool we need to install is Vivado. We will use Vivado 2022.2. I think it can be found in this link. And also, in addition to that, I think you can get a board file from from Digilent, and this file will help you to do some design if you use IP integrate and in Vivado, and we will do that in the following episodes when we get to do some say board design in schematic, I would say, with IP integrate. And also the instructions also for installing those things can also be found from Digilent website. So let's take a look. And here is how to download the tool and install the Vivado. Please use 2022.2. And also during the installation, if you want to save space, you can just choose the 7 series for devices. Otherwise, if you install other devices, it might take just extra space for on your disk. And also, I think, yeah, here is the instructions from Digilent, which will help you go through all the details for installation, and also for the board file they provide. Because if you look at their GitHub from Digilent, I think let me see. Yeah, here's their GitHub, which has all the board files for all their board. This is the one we gonna use, and I think here's the board file. But you can, I think they give you instructions. Oh, sorry, they give you instructions on their website. Just tell you how to, after you install the Vivado, how to copy this board file into a Vivado directory to install the board. And here it will be end of it. Close to the end of this document, they will mention this. So just follow the instructions to do that. And also don't forget, after done with the installation, make sure that the default path, I think is this, should be in the system path, because we're gonna use that later in our command line. So make sure we have it. System path, I think you can in the settings, if you go to system about, and yeah, do the environment, make sure you have it. I think, yeah, make sure this is in the system path. Okay, let's go back to our slides. Okay, so make sure we have installed the tools, and then if you can just skip other devices, but make sure you install the 7 series. Now let's see how we can build the Hello World. Let's start from scratch. Okay, we can still clone, and we use this tag. Okay, now we have that. Let's open a command prompt. Okay, go to Hello World, and then go to scene directory. Now here we have a build.cmd. That's the main one we're gonna run. Let's see what happened. Okay, now it starts to run. The first step is to do a SBT, because we're gonna generate a blinking LED. So we want to make sure the frequency is really low, so our eyes can catch it. So we will set the frequency to be only 3 Hz. So that's why we doing the SBT to regenerate and config our Verilog file for the Hello World. Actually, the Hello World, the core of the Hello World actually is an NCO counter, as we mentioned in the previous episodes. And then we start to create a project, a Vivado project, and start to do the synthesize and place and route. So this will take a few minutes. So in the meantime, let's take a look at the build.cmd. So the build.cmd will let's open it in the. Okay, see what it does is first is the SBT, as I mentioned, and it config the main clock to be 100, but the output clock is 3 Hz. And then it will call the Vivado to create, actually was running this tickle script to create a project. Then it will start to, after this project was created and the synthesizer and place route was done, it will check out the timing summary to make sure that the timing either passed or failed. So we check the timing. And also let's check the build.tickle. That's the main one to be run to create the Vivado project and to run everything here in Vivado. What it does is it includes the top level file, and this is the one we generated as the NCO counter, and this is the XCC file for our constraint. And this we create a clock based on the onboard 100 MHz oscillate. We will create a clock. It's also 100 MHz. And this is, we generate the clock, and then we save it as a project. This is also, we want to generate a bin file, because we're going to use the bin file to program the flash later. And then see, we launch the implementation and then just wait for it to finish. So this is the main part for the Vivado. Okay, let's see if stuff has been finished. Okay, still running. And let's also take a look in the meantime. Let's take a look at the constraint file. The constraint file is first, it's for timing. It will create a clock as 100 MHz. This is oscillate coming incoming oscillate, onboard oscillate with 100 MHz. So we need to create a clock for that. This is a base clock, and this is our constraint for the voltage level and for the pin location. And this part is just set our bit stream for the bin, I believe, for the bin. So some property we need to set up for our board. And also let's take a look at the top level file. The top level file is in the source Verilog. Okay, so this is a system Verilog file. What it does is it has this is all the push button, switch or LED on the board, and we create a clock here, which is the MMCM, I just mentioned in the Beautico. In the Beautico, I think we created this one. This is the part that we created the clock. And then this is the NCO counter we generate through this Spinal HDL. And here's the LED part. You see, this LED it's it says to reset N, which is basically reset N is the lock, PLL lock. So if PLL is locked, it means it will go to the green. Otherwise, it will go to red. And so in normal condition, PLL should be locked, and we should see a green LED. And also, this is the NCO LED is the one that we based on the NCO clock. We will flip the LED. So you will see, supposedly you will see a blinking blue LED on this one, and those two are connected to a push button. Later we will use the put a switch debouncer on those buttons, but for now they are connected directly. And okay, so that's that for the top level. Let's go back to see if we have it. Okay, now it's done. The present route is done, and also timing has passed. Let's take a look at the directory. In the scene directory, now we have a new directory, which is the project name, and then here's the Vivado project, and then the bit files are in here. And you can see actually we have two bit files, which I'll show you. One is this is just a bit stream, but it only programs the SRAM on the FPGA, so it won't survive. It will not survive power cycle. But this one it will program the onboard flash, and onboard flash will in turn program the FPGA during power up. So this, you can say this one will survive the power cycle, and it will be automatically loaded every time when we reset or power cycle the board. So let's see how we deal with that. So how we do that. Let's see how we do the how we program the board. So go open Vivado. Okay, then open hardware manager. Okay, the first time I think you can say open target, since our board has already been connected here. So so the power is already on. So we after power, you can just say open target, auto connect. It will auto detect the FPGA. Okay, now see the FPGA. Let's make it smaller, so like this. Yeah. Okay, so we can see both. Okay, let's do okay. Let's first program the FPGA with the bit stream, and it will load the SRAM on the bit on FPGA. Okay, now we have the blinking LED. the blinking LED is in blue, and the one in green shows that the PLL is locked. And also, if we push a few buttons, I think we have two buttons connected, so we can see they can be controlled by the button for those two LEDs. So, but the main one is the blinking one. So now that's good. But as I said, this one is bitstream. It will not survive the power cycle. Or I would say, if we reload the FPGA, it will be the SRAM will be cleared. So the content will be lost. Let's see if we press this button, the reset button. Let's see, it's gone because the FPGA has been reset, or the SRAM inside was config SRAM inside was all cleared. So in order for this to survive the reset and the power cycle, what we can do is we can program. We have a bin file generated. Remember earlier we have a bin file generated that is for the onboard flash. So let's do this. We can do add a config memory device, and then make sure you choose I think you should choose this one. This is the one that matches our onboard flash for for FPGA configuration. Just choose this one and say okay. Now we're going to choose this bin file. This will program the onboard flash for FPGA configuration. Since it's programming the non-volatile flash, it will take longer. Also, please notice that this LED, this green LED, is indication of it's a kind of like the down signal indication of the configuration of this FPGA. If it's not on, means the FPGA is blank. And now it shows just something is loaded from the flash, configure flash, but nothing happened because it's a blank flash. But after we program the flash, and if we push this button again, we will see the blinking LED again. The LED will start to blink again. Let's see what will happen. Okay. Now we haven't pushed the button yet. Now if we push the reset button, now you see first this LED is on again, shows the FPGA has been successfully programmed, and also we see the blinking LED, but this time it survived the reset. Okay, now if you want to erase the flash, what we can do is we can do the erase part. Okay, now if we do the reset again, nothing happens because the flash is has been erased. Now it's a blank flash, as it was before. So okay, so that's for the live demo. Let's see and anything left on our slides. Okay, so just build just build a command and build ticker, which we already mentioned. Go through the SBT, then create the Vivado project, build the project, and then check the timing. And then here are the two files we generated. And here's the blinking LED. Okay, I think that's all. Thank you so much for watching. If you think this episode is interesting, or just or you think this is helpful to you, just please subscribe. And thank you so much for watching, and see you next time. Bye bye.